Welcome to another Intermediate Algebra video. In this video, we'll look at factoring techniques, a large review of factoring in general, and then we'll learn a couple new techniques, factoring difference of squares and some difference of cubes. All right, so here are our objectives. Review factoring, and I have to give you the warning that one of the goals for intermediate algebra is not factoring. Factoring is a skill that you are supposed to have coming into this class. So this will be the only video where a thorough review on how to factor is done. If you know that factoring is something that you struggle with and the videos I have aren't enough for you, you may need to seek some outside assistance with it. Tutoring Center, YouTube, Khan Academy, tons of resources are out there. But I need to be fair with you and let you know that I'm not always going to go over, except for this video, exactly how to factor the problems. A large portion of this unit involves factoring as a first step. And so in this video, we do a review of it, but once we get into the next videos, the factoring is just something I might kind of breeze by. I'll go through, okay, here's what it factors to, and then do whatever the new information requires. So this will be the only video where we look at it. And I know it's harsh to say that, but that's not one of the goals of this course. So I'm definitely not saying that if you don't remember at this moment how to factor that you're in trouble. This is a refresher video to bring you back up to speed with it, but I just want you to know if you struggled with it or if you've never seen it before, then you may have to do some additional outside work for yourself on it. So first objective is to review factoring, and then we'll learn two new techniques for factoring, one of which there's a good chance you've seen before, and that's factoring with difference of squares and then factoring some difference of cubes. We have formulas for each of those. Okay, so just kind of a reminder on a suggestion, a guideline you can use to factoring. I'm going to add that. This is a guideline. You most definitely do not have to follow this specific order for factoring, but if you need help with factoring, I would say this is one way to help you get better at it, is to be able to follow this method. So the first thing we will always look for when we're factoring is a GCF, which is a greatest common factor. So it's the biggest thing that all of the terms have in common. All right, that's the first thing. Then, depending on the number of terms, you choose a specific method. If you have 4 terms, you'll use factoring by grouping. If you have 3 terms, you'll use any one of the 3-term methods. AC is typically the most common. You may have seen X factor, trial and error. There are tons of them out there, so it doesn't matter which one you use. The one that I'm going to use is AC, just to stay consistent. And then if you have 2 terms, you attempt to factor with difference of squares or some difference of cubes. And then I have the formulas for each of those new methods of factoring. So difference of squares, if you have a squared minus b squared, or if you start out with something that you can write as something squared minus something squared, it factors to a minus b times the quantity a plus b. This could be written the other way. Anytime you have factors, the order of those factors does not matter. The components inside each factor need to be in the right format, but the order of the factors themselves, first, second, doesn't matter. Okay, the sum of cubes formula. So if you have something cubed plus something else cubed, you can write this as a plus b times the quantity a squared minus ab plus b squared. If you have difference of cubes, a cubed minus b cubed, you can write in the format a minus b times the quantity a squared plus ab plus b squared. These are formulas that you'll need to know to be able to factor if there are 2 terms. Something I want to point out to you, because you will need to know these formulas. So what do you recognize about the 2 formulas? Difference of squares is pretty basic, and with a little bit of effort you can get it in your head. But sum and difference of cubes, the formulas are a little more complex. So take a moment and try and identify what are some tricks you could use to memorize these two formulas? The first thing I would point out to you is that all of the variables are in the same spot. It's all a, b, a squared, ab, b squared. So if you can memorize one of the formulas, you at least have the framework for the other. Okay, another thing I would point out is that if the given problem has plus, then the first sign you see is plus. If the given problem has minus, the first sign is minus. So it starts with the sign in the problem. Then the next sign is the opposite. Next sign is the opposite. And the final sign is plus. This is just to be able to help you find a way to memorize these formulas, because you'll need to have them memorized to use them. Okay, so to reiterate the big picture of factoring, first look for a greatest common factor, then depending on the number of terms, you'll use a specific method. Now, it is true that if greatest common, the first step that I have listed, it's true that in some cases it's okay if you do it last. If it's not the first thing you look for, then it needs to be the last thing you look for. But there are a few cases where it's not possible. If you don't take GCF out first, then you won't be able to use the other method and you'll miss the factoring completely. So I would really encourage you to make that the first thing you look for in every problem. And once we start getting more into problems that involve factoring, it's the first thing that'll be forgotten from your head. You'll look at it and say, 4 terms, go, start doing by grouping. But the truth is you really should look for a greatest common factor first. All right, so let's go through some problems together. We're going to start out with the review problems that only use the methods that are supposed to have been seen before. And then after some practice problems, we'll look at difference of squares and some difference of cubes. Oh my gosh, graph. Whoops. Directions are factor. Sorry about that. Okay, directions say factor. First thing we look for is a greatest common factor. There are 4 terms in this problem, so the common factor would have to come from all of them. We're looking for something they all have in common that can be divided out. 3, nothing else has a 3 that could be divided out. The 12 does, but nothing else. X, only one other term. Y, only one other term. So there's no greatest common factor. Then we have 4 terms, so we go into our 4-term method, which is factoring by grouping. In by grouping, we separate into the first 2 and the last 2. When we look at these first 2, then we take a greatest common factor from the first 2. So just focusing on 3xy minus 2x, what do they have in common? They have an x in common. So we take that and divide it out or pull it out of both terms, which leaves us with 3y minus 2. Okay? Then we look at the last 2 terms. Do the same thing. Ignore the beginning. What do these last 2 terms have in common? You might say a 2. They're both even. And that's true, but you want to take out the biggest thing they have in common. So not only a 2, but a 4. You can take out a 4 from this problem. Okay, so we'll take out a 4. Let me show you what that would look like. If we took out a 4 from this, we would be left, now you're dividing by 4, you're left with negative 3y plus 2. Within this method, we want what's inside of the parentheses to be exactly the same in the 2 positions. This is close, but it's not quite the same. The thing that's wrong with it, the signs. So how can we change that? we chose to take out positive 4. What if we took out negative 4? That would leave us with positive 3y and negative 2. And that's your goal in this by grouping method. Okay, so once we've done this first step, then we look at x times 3y minus 2 and negative 4 times 3y minus 2. And we say, what do these two have in common? The thing they have in common is the factor 3y minus 2, just like you did previously. And then you say what's left over. So open parentheses, what's left? Well, we took this out, so x is left, and we took this out, so minus 4 is left. Oof. And this is how the problem factors. Factoring is the undoing of distributing or FOIL. So you can test your work if you want to by distributing, or in this case FOIL, 3y times x would give us 3xy. 3y times negative 4 would give us negative 12y. Negative 2 times x, negative 2x. Negative 2 times negative 4 plus y. So factoring is undoing that multiplication. Information is presented to us in lots of different ways. And in math, we often learn how to do something forwards and then backwards, how to do the operation and how to undo the operation, depending on how things are presented to us. All right, so this is using by grouping. Next problem. We have 5b squared minus 35b plus 60. Okay, first thing, we look for a greatest common factor. Is there something that all three of those terms have in common that we could divide out? In this case, they do, and it's a 5. If we take that out, then we're left with b squared minus 7b plus 12. That's the first step. This one does have a GCF. Then we are left with 3 terms, so we attempt a 3-term method. You can use whichever one you want to. I'm going to use AC. B squared minus 7b plus 12. I'm going to pull this off to the side. This is where I want my answer to go, so I can work on it over here. So the AC method comes from the setup of a problem saying ax squared plus bx plus c. A and c being the coefficient on the squared term and the constant at the end. In this method, multiply a, invisible 1, times c, which is 12, and then look for something, a pair of numbers that multiply to give you positive 12 and combine, add, subtract, to give you this middle term, negative 7b. All right, so we could have 1 times 12, that would give us 12. We could have 2 times 6, we could have 3 times 4. And our numbers need to be both positive or both negative to multiply and give us positive 12. Okay, we're looking for a combination of these numbers with either plus plus or minus minus to give negative 7. So which one works? 3 and 4 combine, and if we make them both negative, negative 3, negative 4 gives us negative 7b. So within this method, then we take that middle term and we break it apart into those chosen numbers, negative 3, negative 4. So instead of negative 7b, we have negative 3b minus 4b. Once you've made this decision and gotten to this stage, the rest of the factoring looks just like by grouping. So we'll break this apart. What do the first 2 terms have in common? A b, leaving you with b minus 3. What do the last 2 have in common? Again, you might say 2, you might say 4, but know that your goal is to have the stuff left over, in parentheses, be the same as the initial one. So if we took out positive 4, our signs would be minus plus. We want plus minus. So I'll take out negative 4, which leaves you with b minus 3. Okay, the last step of by grouping, look at these 2, take what they have in common, b minus 3, pull that out in front, and say what's left over, b minus 4. You might be wondering, okay, well, the numbers were -3 and -4, and that's what my parentheses ended up having. Can I just do that every time? The answer is only if there's a 1 as your a value. It'll work like that if your a value is 1, but if not, it doesn't work like that. So I would suggest just kind of follow this format for all the problems. Okay, so let's pull that back into our ultimate problem. We have 5 times the quantity, b minus 3, b minus 4. The GCF is part of the answer, and the 3 terms factored into these 2 sets of binomials. I just had another common question in my head, and it's gone. Oh, another common question at this stage is, I chose to write -3b minus 4b. Could the two be flip-flopped? Could you write -4b minus 3b? Yes. This step will look a little bit different, but your final answer will still be the same. And then another question, could these two factors be flip-flopped to say b minus 4 and b minus 3? Absolutely. That's not a problem. The only thing that's standard is to write a greatest common factor in front. Any other factors, and truthfully, it's okay if the 5 was in the middle. You could write b minus 3 times 5 times b minus 4, but it's standard just to have that number be in the front. All right. Oh, so this method is AC. We had a GCF, and then we also use the AC method. All right, one more together. Okay, so first thing, we look for a greatest common factor. Looks like all of these numbers have a 7 that can be divided out, and each term has a y. 2 of them have an x, but they all would need to have that x for it to come out as a greatest common. All right, so take 7y out and then say what's left from each of the terms. So we have 2x squared minus, skipping one, plus, take the 7 out of here, we have 3y minus 5x. Oh no, no y here either. There we go. 2x squared plus 3 minus 5x. We took out 7 and y from each of these terms. All right, so there's GCF. Our second method, our second step is then to choose a method using the number of terms. We have 1, 2, 3 terms, so we'll try any of the 3-term methods. We'll go with AC. All right, remember to use AC, it needs to be in this specific format. Our problem is not presented that way, but we can manipulate it. We need the x squared term first, the x term second, and the c last. All right, AC is 2 times 3, which is 6. So we want 2 things that multiply and give us positive 6 and combine to give negative 5. And this is where it can get tricky. All right, so we look at 1, 6, 2, and 3, and you say 6 minus 1 is 5, or 1 minus negative 6, that's negative 5, or negative 2 and negative 3 is negative 5. So I could pick either one, right? Not exactly. There's only one way to factor every problem. So what we need to take into consideration is the fact that 6 is a positive number. So we need these 2 numbers to multiply and give a positive. So it's either plus plus or minus minus. Since that middle term is a negative, we can rule out that it'll be plus plus, which means we need both things to be negative. So negative 1, negative 6 gives us negative 7, not what we want. Negative 2, negative 3 gives us negative 5. So this is the winner. All right, so then in this method, we take that middle term and break it apart. Minus 2x, minus 3x. I'm taking negative 5x and breaking it. This simplifies back to the same thing. I'm not changing any of the information. I'm just stretching the Play-Doh and looking at it a different way. Okay, then we use by grouping. So the first two have a 2 and an x in common. When we take that out, we're left with x. And a very common mistake is to say, well, I took out the 2 and the x, so nothing is left, and close the parentheses. But your goal is to make sure that what you're writing represents the same previous step. So the only way we have the same thing is if we write a placeholder. There has to be a -1 there. The reason, if you were to redistribute this 2x back into the parentheses, you'd have 2x squared minus 2x. You need the 1 there to get the 2x to appear again. All right, then the last two terms, they have a 3 in common, but again, we need the signs to be opposite, so we're going to take out a -3, leaving with x minus 1. And then the last step, they have x minus 1 in common, leaving 2x minus 3 left over. So 7y times the quantity x minus 1 times the quantity 2x minus 3. Again, we used a C for this second part, getting us our final answer. It won't always happen that there's a greatest common factor and then also another method used. In this section, in this video, what we're looking at is factoring. That's the entire goal of what we're doing is factoring. So right now, the practice on all the different methods is what's coming into play. But once we move on from just the objectives of factoring, factoring will be step 1, and then we'll be doing something else. So it won't always be quite as intense of factoring. Sometimes it will be, but sometimes it won't be. Okay, so let's go ahead and do some practice problems. I have 3 total listed for you. 1, 2, 3. I have space for 1 and 2 on this page, and then the next page has the third one. Go ahead and go through these, and then we will go through them together in a moment. Okay, so our first problem. You should have practiced these on your own. Factoring is of the utmost importance as we continue on, and it does not go away as you continue through the math courses. All right, so our first problem, first we look for a greatest common factor. AB, 9A, 2B, 18, they don't all have anything in common. So then we use by grouping. The first two have an A in common, leaving you with B plus 9. The last two have a 2 in common, leaving you with B plus 9. And I'm glad we have a problem like this because everyone so far we've pulled out a negative number as the second piece here. This is a positive that we pulled out. So a very, very, very common mistake that I see is to then say, okay, we have B minus 9 times the quantity, and they say A and 2 because there's not any sign sitting there. And this is not right. If we re-multiplied this, we would only get 2 terms. We wouldn't get 4. So it's very important to write the plus in the middle here so that you know it is an A plus 2. Now, truthfully, at this stage, on this second line, if you don't write the plus, technically it's okay. But if the plus does not exist in the final answer here, it is wrong. Any online homework system will just say wrong. On a test, you would lose some points. You'd get partial credit, but you would definitely lose some points because it should say plus. All right, there's the first problem. We only used by grouping. The second problem, first look for a greatest common factor. We don't have one. We can go right into the AC method. So we have 3 times 24. Oh boy, 72. 5. Don't have the calculator with today. 72. Okay, so we need 2 things that multiply and give, ooh, my mistake, even more. Let's take that out. 3 times negative 24, which gives us negative 72. So we need 2 things that multiply and give us negative 72, and add subtract to give 14, positive 14. This means our numbers have to be a positive and a negative. That's the only way we multiply and get a negative. And if it was me, I would just start writing down the options. Could be 1 and 72, Could be 2 and 36. 3 and 24. Does 4 work? 4 and 18. 5 doesn't work. 6. 6 and 12. And then 8 and 9. So these are all our options for numbers that multiply and give 72. We need one to be positive, one to be negative, and they need to combine to give 14. So which combination of 1 plus 1 minus gives us 14? The answer? 4 and 18, but what should their signs be? We need a positive number in the middle here, so we want positive 18 and negative 4. Okay, so then take this middle term and break it apart to minus 4x plus 18x minus 24. The only thing that happens in this AC method, next step, is we break apart that middle term and then use by grouping. The first two have an x in common, 3x minus 4. The last two have a positive 6 in common, leaving you a 3x minus 4. If you only recognize 2 or 3, and that's what you took out, they do have that in common, but it needs to be the greatest common factor. Because remember, these parentheses need to be the same, otherwise the whole method falls apart. These are the same. The thing they have in common is the 3x minus 4, and you're left with x plus 6. Again, the order of those two factors does not matter. There we go, AC. All right, and then our third practice problem, 9ab squared minus 12ab plus 21a squared b cubed. So first, a greatest common factor. They all have a 3 and an a and a b. If we take that out, we're left with 3b minus 4 plus 7, a single a, and b squared. And your next attempt would be factoring with a 3-term method. Trial and error, AC, X factor, there's tons of them. But it would need to be in that specific order. So move the squared term up front. And then C, does it fit the format of A, X squared, B, X, C? And the answer is no. We have the B squared, B in number, but this A throws everything off. If there's one single extra random variable in there, you can't use the 3-term method. It won't work. There's nothing to do to factor it. So for this one, this is it. Whether you reorder or not doesn't matter. The answer can be either one of these. But this A is the problem. And we factored it correctly. There were 2 A's in this last term, so when we took one out, one had to be left over. But this one does not factor any further. Okay. All right, let's look at factoring using difference of squares and sum difference of cubes. If you don't have the formulas handy, go ahead and flip back to the page, maybe copy these down somewhere else so that you can reference them. Our first problem, b squared minus 49. So for this problem, we're looking to see, first of all, if there's a greatest common factor. Our goal is still factor, and we don't have one. So then we go into our 2-term method. Do we have difference of squares, sum difference of cubes? Well, the only thing that we can even consider is difference of squares because the b has a squared power on it. So for us to use difference of squares, let's rewrite. We need to know what the base is for each of these things being squared. So the 49 is typically, the number is usually the easier one to look at. What squared gives us 49? The answer is 7. So the base, the b, is 7. What squared gives us b squared? Easy enough, b. So this is our a. This is the a and b that we're plugging into this formula. So it gets set up like this, a minus b, a plus b. So b minus 7, b plus 7. And that's it. Difference of squares is pretty simple. You just need to know what the bases are. And you might look at this and be able to fill in the formula without writing it in this format, but it'll help when we go to the sum difference of cubes to see it in this format. Okay, so let's look at this second problem. We have 8a to the third plus 27b to the third. First of all, look for a greatest common factor, always our first consideration. We don't have one, so then go into our two-term methods, which are difference of squares or sum difference of cubes. We have sum of cubes. Third power on each of these, so it's the only one we can consider. So now let's see, can we write each of these as a quantity cubed? What would it take to get 8a cubed? What number cubed would give you 8? Start there. You can test numbers in the calculator. You can plug in 1 cubed, 2 cubed, 3 cubed until you get this number. The answer for this one is 2, along with a. So this is our base. That's the a. For the second one, we need the number cubed. That would give us 27. That number is 3. And b. So this is our b. And then we plug this into the formula. I'm going to write the formula. So remember, to know this formula, it's plus, so it starts out with plus, a plus b. Then the variables are always the same, a squared minus, because we had plus, ab plus b squared. So fill this into the formula. A plus b. Our a is 2a, our b, 3b. Then the second piece, a squared. Well, our a is 2a. So what does this give us? 2a squared means 2a times 2a, which is 4a squared. This is a very common mistake. I often see students find the base correctly, but then write 2a squared. But it's not the case. It's the entire thing that's squared, which becomes 4a squared. Don't forget to square the number. Okay, then that middle term is ab. Our a is 2a. Our b, 3b. They multiply and give you 6ab. And then the last term is b squared in the formula. So our b is 3b, quantity squared, means 3b times 3b, which is 9b squared. So plus 9b squared. Now, it is possible that more factoring could happen here. Typically, I wouldn't expect that to happen. Once you use this formula, you've got it. The three-term piece will not factor. The only way it would is if there was a greatest common and you somehow missed it. In this first piece, I wouldn't worry about it, but it's always possible for there to be more factoring. So this one used the sum of cubes. It's the sum because it's addition of cubes, things that were cubed. The first one was difference of squares. Something to point out, for cubes we have a sum formula, an addition, and a difference formula, subtraction. But for squares we only have a difference formula. So if you see a problem that says b squared plus 49, you can't factor it. That's it. That's as much as you could do with it. There's always the potential for a greatest common factor, but this one specifically doesn't have one and it doesn't factor any further. Okay. 2 more together and then some practice problems. Our next one, start out with a greatest common factor. Do we have one? These terms definitely have a 2 in common. They're both even. So let's start there. That should be it. You can test on the calculator. If we take 2 out, then we have 27x cubed minus 125y cubed. Still following those steps for factoring. First look for a GCF, then depending on the number of terms, try a method. We have 2 terms, so it's either potentially difference of squares or some difference of cubes. We have difference, and we have 2 things that are cubed, so we can use difference of cubes. All right, so we need the bases. So what cubed gives us 27? The number's 3. What cubed gives us x cubed? X. What cubed gives us 125? May have to play in the calculator to find that one. It's 5. And then what gives us y cubed? That would be y. So here are our bases, 3x and 5y. Now, the 2 is part of the answer, so tack it onto the front right away, do it later, doesn't matter. So this formula is difference. Start out with 3x minus 5y times the quantity. This base squared, which is 9x squared. Then AB (15xy). The first sign was plus. First sign was minus, so this one's plus. And then the last piece, 5y squared. 25y squared. And this is always plus. And this is the fully factored version of this initial problem. Anytime the directions say factor, they mean factor as much as possible. So you might look at this first line that we wrote here and say, well, I did some factoring, but just like simplifying, if it says factor, it means do as much as possible. All right, one more together. 1/9 minus 25x squared. I would not expect a lot of fractions in your factoring, but it's possible. And this section is focused on the art or the methods of factoring. Okay, so first we look for greatest common factor, and these 2 terms do not have anything in common. So then we try a 2-term method. Is there anything we can write these either bases, squared or cubed? Well, squared is definitely our only potential because the second term is squared. And that's the easy one. We can write that as 5x quantity squared, so that gives us the base. But is there any way to write 1/9 as something squared? Well, as a fraction is kind of difficult to see, but if you look just at the numerator, is there anything that gives you 1? What squared gives you 1? 1. What squared gives you 9? 3. So 1/3. Remember, fraction multiplication is straight across. Okay, so we have the bases, and then we just fill in the formula. This one is difference. We have subtraction, good, of squares. So the formula says a minus b, a plus b. So 1/3 minus 5x, 1/3 plus 5x. If you flipped those 2 factors, that's fine. There's no need to simplify those fractions in any way. It's good enough. All right, so this was a look at factoring some difference of cubes and difference of squares. So go ahead, pause the video, practice these 2 on your own. We'll go through them in just a moment. Do not be fooled by the first problem. Okay, let's take a look at them together. Our first problem, it's very tempting to look at that problem and say, difference of squares. I see a 64, which is something squared, x squared, 100, that's something squared. But the first thing you have to look for is a greatest common factor. And those 2 terms do have something in common. They definitely have a 2. Even more so, they have a 4 in common. Take out that 4. This leaves you with 16x squared minus 25. then continue. You have two terms, attempt a two-term method. Something squared, so the only thing we try is difference of squares. We have difference. We can write each of these bases as something squared. The first term, 4x. The last term, 5. So the 4 is on the outside, and we have 4x minus 5, 4x plus 5. This is your difference of squares formula. This is the answer. What I often see students do, it's a very common mistake, is to start out with this problem by doing difference of squares right away. And it can work out if you do it that way. If you factor difference of squares right away, you'll have 8x minus 10 times 8x plus 10. But remember I mentioned if you don't do greatest common factor first, then you have to do it last. So we didn't do it first, check last. Do each of these factors individually have a greatest common factor? They do. Each one has a 2. If you take out each of those 2's, then you're left with 4x minus 5, 4x plus 5, and then it would be expected that you then pulled the two numbers together, multiply them, and you have 4 times 4x minus 5, 4x plus 5, which is exactly what we got doing it the other way. So this is a good example of a problem where it didn't necessarily matter if you did it first, but there are times when it won't work. If you don't look for greatest common first, you won't find it. The problem we did on the previous slide, the first one with the cubes, if we hadn't taken that 2 of a greatest common factor out, we wouldn't be able to do difference of cubes or sum of cubes, difference of cubes. And then the entire problem, you would say, can't be factored. So I highly encourage you to do greatest common first. Okay, and then our second problem, y cubed plus 1. This can be a tricky one. There's no greatest common factor, so then you decide, can I write each of these as something cubed? Well, you can definitely write the y cubed as y to the 3rd power, but what about the 1? Can you write that as something cubed? It's a 1. So these are your bases that you plug into the formula. This is plus, so we have y plus 1 times the quantity, this base squared, minus a times b, so 1 times y, which gives you just y, plus this b term squared, which is 1. So this also factors. And that's as far as it goes. All right. Okay, so this video was a review on factoring methods, followed by instruction on 2 potentially new methods, difference of squares and sum or difference of cubes. So please watch extra videos if you need to. Spend the amount of time getting the factoring skills down because they will be very important as we move forward within this next unit.